Hello students, in this video we will be starting chapter 2 fractions and decimals. Because this is quite a big chapter, we will be dividing it into parts. The first part is the fractions part. We will have the introduction with exercise 2.1, then multiplication of fractions, exercise 2.2, multiplication of a fraction by a fraction, followed by exercise 2.3, division of fractions, and finally exercise 2.4. The next section is the decimal section, which will have the introduction with exercise 2.5 first, multiplication of decimal numbers along with exercise 2.6, division of decimal numbers, and finally exercise 2.7. The first part is the introduction. You have learned fractions and decimals in earlier classes. The study of fractions included proper, improper, and mixed fractions, as well as their addition and subtraction. We also studied comparison of fractions, equivalent fractions, representation of fractions on the number line, and ordering of fractions. Our study of decimals included their comparison, their representation on the number line, and their addition and subtraction. We shall now learn multiplication and division of fractions as well as of decimals. Let us recall what we have learnt about fractions. A proper fraction is a fraction that represents a part of a whole. So one thing you can always remember about proper fractions is that their value is less than 1. And proper fractions will always have the numerator lesser than the denominator. Is 7 by 4 a proper fraction? Which is bigger, the numerator or denominator? So looking at 7 by 4, you can tell that 7 is bigger than 4. Therefore, it is not a proper fraction. It's an improper fraction. However, 4 divided by 7, this would have been a proper fraction. This is because the numerator 4 is less than the denominator 7. An improper fraction is a combination of a whole and a proper fraction. So an improper fraction is a combination of a whole number and a proper fraction. Is 7 by 4 an improper fraction? Which is bigger here, the numerator or the denominator? In this case, 7 is bigger, therefore it is an improper fraction. The improper fraction 7 by 4 can also be written as 1/3. So I hope you remember how you can convert an improper fraction into a mixed fraction. A mixed fraction is that which has a whole number and a fraction in it. In this case, we have 1 as the whole number and 3/4 or 3 by 4 as the fraction part of the mixed fraction. So I'll just remind you how we can convert 7 by 4 into 1/3 by 4. What you need to do is you need to divide 7 by 4. So when you divide 7 by 4 completely, you will get 1, whereas the remainder is going to be 3. Then all you need to do is then write the denominator as it is. So we'll have the quotient here, the remainder here, and the denominator copied down exactly as it is. That is why we get 1/3 by 4 when we convert 7 by 4 into a mixed fraction. Can you write 5 examples each of proper, improper, and mixed fractions? I will leave this activity to you. Just remember, in a proper fraction, the denominator is always greater than the numerator. In an improper fraction, the denominator is less than the numerator. And to convert improper into mixed, what you need to do is you need to divide the numerator by the denominator and then keep the remainder as the new numerator and the quotient as the whole number. You can write 5 examples each. Let us move on for the examples. Example 1. Write 5 equivalent fractions of 3 by 4. In the previous classes, you would have learned that equivalent fractions are those which have the same value. So, equivalent fractions should have the same value. This means that after simplification, all equivalent fractions will reduce to the same fraction. For example, for the fraction 3 by 4, if you want to calculate equivalent fractions, what you need to do is you need to multiply the numerator and denominator by the same number. For example, when we are multiplying it by 2, we get the equivalent fraction 6 by 10. Similarly, we can also find other equivalent fractions. For example, if you choose to multiply the numerator and denominator by 3, we will get 9 by 15. Just keep note that from here in forward, I will write fractions like this instead of writing one below the other. So in this case, 9 is the numerator and 15 is the denominator. Similarly, if you want to multiply it by 4, then you will get 12 by 20. You can also multiply it by a greater number, say 100, in which case you will get 300 by 500. All these are equivalent to 3 by 4. In their simplest, in their reduced forms, you will get back 3 by 4. Before we move on, just remind yourself, is 3 by 4 a proper or improper fraction? You can take some time to think. The answer is, it's a proper fraction because the numerator is less than the denominator. So the value is less than 1. Up next, we have example 2. Ramesh solved 2 by 7 part of an exercise while Seema solved 4 by 5 of it. Who solved the lesser part? So we need to compare these two fractions, 2 by 7 and 4 by 7. If you just recall from your previous classes, an easy way to compare fractions is to reduce them or is to simplify them to form like fractions. So we need to change these two fractions to form like fractions. Like fractions are those which have the same denominator. So these fractions have the same denominator. When you have the same denominator, for example, compare 1 by 3 and 4 by 3. These two have the same denominator, that is 3. So it is easy for us to compare, and you can easily say that 4 by 3 is greater than 1 by 3 because 4 is greater than 1. As the denominator is the same, we can compare these two fractions directly by comparing the numerators. So for us to compare 2 by 7 and 4 by 5, we need to convert them into like fractions. In order to find who solves the lesser part of the exercise, let us compare 2 by 7 and 4 by 5. So how can we convert these two fractions into like fractions? We learned that like fractions need to have the same denominator. So we need to work with 7 and 5 such that they're both converted to the same number. One way to make that happen is to multiply 7 by 5 and 5 by 7. And whenever we are multiplying the denominator, we also need to multiply the corresponding numerator with the same number. So what is going to happen is, we need to multiply 2 and 7 both by 5, and we need to multiply 4 and 5 both by 7. I have just written down the working here for you. Like I said, we need to multiply 4 and 5 both by 7. So we will be getting 28 by 35. Whereas for 2 by 7, I have just written it down here. we need to multiply both numerator and denominator by 5 so that we get 35 in the denominator, and the numerator it becomes 2 5s are 10. Now we have two like fractions, that is 28 by 35 and 10 by 35, because they both have 35 in the denominator. What we need to do is we need to compare 10 and 28. We will get that 10 by 35 is less than 28 by 35 because they're both like fractions. All we had to do was compare the numerators. This means that 4 by 5 is greater than 2 by 7 because we got 10 by 35 from 2 by 7 and 28 by 35 from 4 by 5. Therefore, 2 by 7 is less than 4 by 5, which means that Ramesh, who solved 2 by 7 part of the exercise, solved lesser part than Seema. So that is the end of example 2. Let us move on to example 3, where we are dealing with mixed fractions. Samira purchased 3.5 kg apples and 4.75 kg oranges. What is the total weight of fruits purchased by her? So here it's a simple question. What we need to do is find the total weight of apples and oranges. But the weight of individuals, that is apples and oranges, they are given in mixed fractions. How do we convert them into the total weight is we first have to change them into improper fractions so that we can add them. Let us convert 3.5 into an improper fraction. How do we do that is, we need to multiply 3 by the denominator and the answer is going to be 6. To the 6 we need to add the numerator. So the answer is 7. Write 7 as it is in the numerator and then copy down the denominator. You should have already learned this in your previous classes. Just as a reminder, what we need to do is, when we have a mixed fraction like this, we need to first multiply the the denominator with the whole number. So multiply 3 with 4. You get 12. To the 12, you need to add the numerator. So 12 plus 2 is equal to 14, and then keep the same denominator. So multiply the whole number by the denominator and add the numerator, keep the same denominator. So the total weight of apples expressed as an improper fraction will become 3 2s are 6 plus 1 7, keep the denominator 2, 7 by 2. Similarly, the 4 3 by 4 kg of oranges as improper fraction from mixed fraction will become 4 4s are 16, 16 plus 3 is equal to 19, and then keep the denominator, therefore it is 19 by 4. Now we need to add 7 by 2 and 19 by 4. The way we can add these two is by once again converting them into like fractions. And how do we convert them into like fractions? Is by first find the least common multiple of 2 and 4. You have learned this already in your previous class. Whenever you have two different denominators, you need to convert them into the same denominator so that you can have the like fractions. Addition of like fractions is very simple. You have to add the numerators and keep the denominator as it is. So the least common multiple of 2 and 4 is 4. And therefore, to convert 2 into 4, we need to multiply it by 2. And we also need to multiply 7 by 2, which is going to give us 14 by 4. So the total kgs is 14 by 4 plus 19 by 4, which is just equal to 33 by 4 kgs. Now, we can also write the answer as a mixed fraction. How do we do that is, we divide the numerator by the denominator. As a whole number, whatever we get, the quotient, we write it here. So 33 by 4 cannot be divided completely. Instead, you have 4 8s are 32. So we have the remainder 1, which goes to be the numerator of the fraction and then keep the denominator as it is. So this is how you convert the improper fraction into the mixed fraction. Now let us see example 4. Suman studies for 5 2/3 hours daily. She devotes 2 4/5 hours of her time for science and mathematics. How much time does she devote for other subjects? So total hours she studies is 5 2/3, and for science and mathematics she studies for 2 4/5. So the difference between these two is going to give us how much time she devotes for other subjects. Again, this is similar to our previous problem, where we just have to convert them into first we have to convert them into improper fractions, and then we have to convert them into like fractions, and then we need to find the difference. Once we have the difference, we need to convert it back into a mixed fraction, and then we can write the answer like this. Just go through this because it's going to help you solve the exercise 2.1. Let us start with exercise 2.1. We have the first question. We need to solve these addition and subtraction problems. Let us do a couple of them, and I will leave the rest of them to you because this has already been taught in our previous classes and you can use the practice. So we'll try to do the first one, 2 minus 3/5. So this 2 can be written as 2 divided by 1, and the way we have to solve this is we need to convert these two into like fractions. So how do we convert them into like fractions is, we need to divide and multiply numerator and denominator of 2 by 5. So that means we will have 10/5. 2 can be written as 10/5. 2/1 and 10/5 are equivalent fractions. So when we write 2 as 10/5, we can then subtract 3/5 from it because these two are like fractions. So the answer is going to be 7/5. Similarly, let us try the last one, 7th one, 8 1/2 minus 3 5/8. So this has two steps. The first step you have to convert them into improper fractions, and the next step you have to convert them into like fractions. As we have seen here, 8 1/2 can be written as 17/2 and 3 5/8 is 29/8. So you know how to convert a mixed fraction into an improper fraction. Just multiply by the denominator and add the numerator, and then keep the denominator the same. So when we do that, we get these two fractions. Next, we have to find the like fraction form of 17/2. We can just convert 2 into 8 by multiplying it by 3. Therefore, we need to multiply the numerator also by 3, where we get by 4, that is 2 4s are 8, therefore 17 4s are 68. So we'll get the difference as 39. The answer is 39/8, and to convert it into a mixed fraction, we need to divide 39/8, and the nearest whole number is 4. The remainder is 7. The denominator, we copy it as it is. So this is the answer for the 7th one. Up next we have arrange the following in descending order. Let us try to do this one. Before you try to convert them into a improper fraction, into like fractions, what you can do is you can try to get an intuitive understanding of this. Look at the first one. This is saying that the top, that is the numerator 2, is less than third of 9. If you have 9 of something, if you have only 2 with you, then you have less than a third of it. So just to get an intuitive understanding, I have drawn here a simple 3-unit rectangle. This is 1 unit, this is second unit, and this is the third unit of it. Now observe here that the second fraction, that is 2/3, this denotes exactly 2 of the 3 units. So that denotes exactly 2 of the 3 units. So these two are represented by the second fraction. Whereas the first fraction, because 1/3 of 9 is equal to 3, the number 2 is a little less than 1/3 of 9. So that fraction is denoting this part. Observe how it is a little less than 1/3 of this. Now look at the last fraction, that is 8 by 21. 1/3 of 21 is 7, so 8 represents a little more than 1/3 of 81. When you think about it that way, so this is 8 by 21. When you think about it that way, it should be easy for you to denote it in a decreasing order. You start with the biggest fraction, that is 2 by 3. Then you start with the middle one, that is 8 by 21. Finally, you go on to the least one, that is 2 by 9. Or we can also convert them into like fractions. So the denominator is going to be 63, which is the LCM of 9, 3 and 21. And the numerators are going to be their corresponding results, after multiplying both denominator and numerator by the same number to get 63. So these fractions will become 14 by 63, 42 by 63 and 24 by 63. So the order is going to be, like we have learned, 2 by 3, 8 by 21 and 2 by 9. This is the descending or the decreasing order. The next question is, in a magic square, the sum of the numbers in each row, in each column and along the diagonals are the same. So if something is a magic square, I think we learnt about this in our previous lesson, that is the integers. The sum along the row, each column and even along the diagonal should be the same. So this is the diagonal. So once you calculate the sum, it should give us the same number. They have done it for the first row. So they have added 4 by 11, 9 by 11 and 2 by 11. That is equal to 15 by 11. You can try it along each of these rows. So the first row is what they have given. This is the second one. This is the third one. Okay, so you can try it for each of these rows and also each of these columns and check it for the diagonal as well. Then if you get all the row sums, all the column sums and even the diagonal sum equal to 15 by 11, then this can be a magic square. The fourth question is, a rectangular sheet of paper is 12.5 centimeters long and 10 2 by 3 centimeters wide. Find its perimeter. So to solve this, you should remember the formula for perimeter of a rectangle, that is 2 into length plus breadth. So the length is given to be 12.5 centimeters and breadth is given to be 10 2 by 3 centimeters. So for us to find the perimeter, we need to calculate 2 into 12.5 plus 10 2/3. How do we add these two is, we need to change them into improper fractions first. So 12.5 is 25 by 2 and 10 2 by 3 is 32 by 3. Furthermore, we need to change them into the improper fractions, and then we have to change them into like fractions. So I had left out to include the multiplication by 2. So we need to be very careful when we are solving such problems. Then when we convert them into like fractions, we have 75 plus 64, both of them by 6. So we can add them up and the answer is 139 by 6 into 2. So the final answer is going to be, as a mixed fraction, 46 1/3 centimeters. So the perimeter of the rectangle is equal to 46 1 by 3 centimeters. Let us try question number 5. Find the perimeters of triangle ABC and the rectangle BCDE in the figure. Whose perimeter is greater? So here we have triangle ABC and AB is equal to 5 by 2 centimeters, BC is equal to 3 by 5 centimeters and AE equal to 3 by 5 centimeters. So again we should recall the formula for perimeter of for a triangle, which is equal to the sum of the three sides, the sum of the length of the three sides. Furthermore, we need to find the perimeter of this rectangle over here, BCDE, whose length is equal to 3 by 4 centimeters and whose width is equal to 7 by 6 centimeters. And we have to decide which perimeter is greater. So here we have the solution to that one. Firstly, the perimeter of triangle ABC is equal to, like we just saw, sum of the length of its three sides. And I want you all to pause the video and try to calculate the sum on your own, and then you can check the solution. So the sum is going to be equal to 177 by 20 centimeters. So the perimeter of triangle ABE is equal to 177 by 20 centimeters. Furthermore, the perimeter of rectangle BCDE is equal to twice the sum of length and breadth, and that is going to give us 47 by 6 centimeters. Then we need to compare these two. For us to compare these two perimeters, we need to convert them into like fractions, and converting them into like fractions is going to give us a denominator of 60, and we will be able to tell that the perimeter of the triangle is greater. So this is the solution for question number 5. Next, let's try question 6. Salil wants to put a picture in a frame. The picture is 3 by 5 centimeters wide. To fit in the frame, the picture cannot be more than 3 by 10 centimeters wide. How much should the picture be trimmed? So, one thing that you may get confused about is which of these is greater. This is 3 by 10 centimeters. Although 10 is a greater number because it's in the denominator, the numerators are the same. Therefore, we can easily conclude that 3 by 5 is greater than 3 by 10. By how much is it greater is the question. Because the picture cannot fit into the frame unless it is less than or equal to 3 by 10 centimeters. So to find the solution to this problem, we need to find the difference between the length of the picture and between the width of the picture and width of the frame. This is actually a fairly simple subtraction because 7 is the same whole number and we are subtracting 3 by 5ths from 3 by 10ths. So 3 by 5 minus 3 by 10. For us to do this, always remember that because 5 is half of 10, this 3 by 10 is exactly half of 3 by 5. So the difference is also equal to 3 by 10. The difference between the frame and the picture's width is equal to 3 by 10 centimeters. Therefore, the picture should be trimmed by 3 by 10ths of the centimeters. Whenever you are solving a statement problem, it is a good practice to write the final answer in the form of a statement. So the picture should be trimmed by 3 by 10 centimeters to fit the frame. Let us go to the next question. The next question is, Ritu ate 3/5 part of an apple and the remaining apple was eaten by her brother Somu. How much part of the apple did Somu eat? Who had the larger share and by how much? So we had a fraction of apple that was eaten by Ritu as 3 by 5 and her brother Somu ate the remaining part of the apple. To find out how much Somu ate, we need to find the difference between the whole apple that is represented by 1 and the part that Ritu ate, that is 3 by 5. So here we have Ritu's share is equal to 3 by 5. Therefore, Somu's share is going to be equal to 1 minus 3 by 5. Whenever you have questions like this, when someone has taken some fraction and you want to find the remaining fraction, you should always subtract it by 1. So you should always subtract the fraction by 1. And the difference is going to be 2 by 5. Therefore, Somu's share is less than Ritu's share. By how much is it less is you have to find the difference between 3 by 5 and 2 by 5 is equal to 1 by 5. So Ritu ate larger share by 1/5 of the apple. Let us see the next question, that is the final question of this exercise. Michael finished coloring a picture in 7 by 12 hour. Vaibhav finished coloring the same picture in 3 by 4 hour. Who worked longer and by what fraction was it longer? Again, before we go into the actual workings of this problem, observe here we have 4 parts and Vaibhav has worked for 3 parts of the hour out of the 4 parts of an hour. Whereas Michael, he has worked for 7 out of 12. If you reduce 12 to 4 parts, then 3 parts of 12 should have been equal to 9. So you can easily tell that Vaibhav has worked for longer. Let us work out using the numbers. Time taken by Michael is equal to 7 by 12. Whereas time taken by Vaibhav is equal to 3 by 4 of the hour. Now for us to find the difference or for us to compare this, we need to make them into like fractions, and by doing that we are changing 3 by 4 into 9 by 12. 9 by 12 and 7 by 12 are like fractions. Therefore we can tell that 9 by 12 is greater than 7 by 12, which implies that Michael has taken lesser time than Vaibhav and Vaibhav has worked longer. By how much has he worked longer is, we have to find their difference, that is 2 by 12 hours, that is 1 by 6 hours. You can also convert it into minutes and write it as 10 minutes. Again, we have to write the statement, Vaibhav has worked 1/6 of an hour longer. Okay, so this is the answer for question number 8. Okay students, this is the end of the first video of the lesson Fractions and Decimals. I will see you all in the next video.